Hello, ETL enthusiasts. Welcome to this presentation. My name is Sriram. I have been preparing Informatica interview related presentations. This is also related to the same one. Instead, I would like to uh, prepare one presentation for all Informatica interview questions and what is the expectations from the Informatica interviewer. Okay, this is Sriram presenting this one. I'm overconfident that if you read this one would be enough for Informatica interview. Okay, so let us start the music. Let us see the agenda for this presentation. Okay, what is the expectation of the interviewer? Okay, of the interview. Okay, let us see the agenda. Okay, let us discuss what is the expectation of Informatica interview. Okay, so it mainly consists of 5 sections, but mostly 3 sections will be mandatory and 2 are optional. Okay, so anyway, the interview should start from what is your current project, okay, roles and responsibilities, okay, that must be there. And second one is basics, data warehouse terms and their basics, maybe 5%, and it's optional for the interviewer, not for you. Okay, Informatica Power Center questions 70 to 80%, SQL 20%, Unix may not be there, that is 5%, depends on the project. Okay, these stars are optional for interviewer, not for the interview seeker. Okay, let us start understanding the first topic, current project. Every interview start with asking explanation of what is your current project, what is your role and responsibilities, what is your experience and other stuff. So that will be covered in this one. Okay, current project, what you can explain him would be the good thing. Okay, so let us start in that way. So tell me about yourself and explain your current project and responsibilities is the first questions you expect from the interview. Okay, so let us see what you have to explain him. Okay, so you start with how much experience you have in IT. Tell him how much experience you have in Informatica and what all are the subjects that you think you are expertise in, like Informatica, SQL, Unix, shell scripting, likewise. Okay, and explain little about your current project, client, okay, and what is this project is about, all is about. Okay, say about your roles and responsibilities and daily activities. Okay, these all are what he is expecting. Okay, if you can explain him what certifications you also got and like AWS, CCP and all those stuff, that would be helpful, but I really don't think he listen to you. Okay, he doesn't bother about anything you explain in this section, because he only bothers about how much experience you have on Informatica, because this is Informatica interview, and he bothers about whether you know Unix or not and SQL. Okay, nothing else. He doesn't really bother about what you are telling about the project and client, because he also worked on so many projects, and you can't simply explain whatever you did in 2 hours in current project with him in 2 minutes or 5 minutes, and he won't understand in 1 minute. So there is no meaning. Okay, let us see next slide. I try to give a little example over there how to explain the current project. Okay, so I have been in IT for almost 10 years. Okay, among I had worked for 8 years on Informatica Power Center, Oracle, Unix shell scripting combination, and 2 years as a SQL developer for XYZ project. Okay, you can tell like this. I have been in my current project for almost 13 months with the client XYZ Bank, and project is enterprise data warehouse. Okay, let us continue with the same example. So current project is enterprise data warehouse with ABC or XYZ Bank. Project is to integrate data from various sources like Oracle, CSV, XML, text data, and Postgres data into Teradata data warehouse. So my target is Teradata in 3 stages. Okay, data flow is like extract data. Please remember, ETL is integrating too, right? So you have to integrate multiple sources data into a database or data warehouse. Okay, that's why I'm saying these things. Data flow is like extract data from various sources and load it into pre-stage, and then apply some few filters, trimming and date formattings, and add some new project specific columns and load it into stage tables. From stage, you may have another database, relational database, that may be for downstream systems. Okay, or you can directly load the data from stage into data warehouse. So here in this case I'm explaining like from stage I load the data into EDW, dimensions and facts. Okay, on top of EDW there may be business objects or a Cognos reporting tool will be working on EDW to provide the reports to the end users. Okay, this explanation would be enough for him. Okay, on the current project. And third part is like your roles and responsibilities. So my role is ETL developer or a lead. Okay, my day-to-day responsibilities include developing couple of modules, performance improvement, unit testing them, document design documents, UTC, UTR, standard operating procedures, run book, those things. And if you are a lead, you are also mentioning that code peer review. So if your other resource also doing some code and you wanted to review on that. Okay, deployment of code from one environment to another environment, it may not be. Okay, to prod. Okay, so assigning tasks to developers, weekly, monthly reports preparation and presenting to managers. If you are a lead, this role will be there, otherwise it won't be there. Okay, so mostly this should be enough to explain developing, performance improvement, unit test, performance improvement and core periods like added advantages to your roles and responsibilities. Okay, he may start with this one. If he is not prepared with any interview questions from internet, then he must be starting from here. What is performance tuning you did in the current project? So you must be booked. So it is better you must understand what you are putting in your resume. Okay, or whatever you are saying here. He may not be concentrating on your stuff, but be vigilant that he may be hearing your stuff. Okay, so let us start with the second section, that is data warehouse basics. Okay, if anybody asks in interview and there's the first question, what is data mart and data warehouse, then you can laugh at him. So those things should not be expected in that project. Okay, anyway, you must know that. That's why I'm not including it. I'm just including whatever is needed for interview. Okay, so expectations for the basics are understanding the data warehouse terms, its meaning, and its real-time example and usage. Okay, in your current project if you used it, so don't tempt that you used it. If you use it, then you must explain it. Okay, so what is a dimension and what are the different types of dimensions you use in the current project, and also what is schema and its types, what is fact and its types, differences between terms like OLAP, OLTP, bitmap, b-tree indexes, and all those stuff. Okay, let us learn more in next slides. Okay, let us start with schema. Schema is a logical design of your data warehouse, or it's like a blueprint for your project. Okay, there are two types of schemas mostly used in EDW in the world. Okay, so starflake, sometimes star schema sometimes, and another one is snowflake. Okay, so star schema, as it suggests, it looks like a star. There are dimension tables surrounded by one fact table. Okay, that is star schema. Then snowflake schema is like normalized structures of the dimension, and fact will be remain same, only one fact, but multiple dimensions and dimension parts. See, one dimension is divided into multiple dimensions here with a relational connection. Okay, that is a snowflake schema. That is the difference between these two. Okay, let us see. Let us understand what is a dimension. Okay, dimension is a table or an entity which is used to store particular subject area data, like say for example product data. Product dimension will consist all the product related data. Time dimension consists of time related data like business date, weekday, quarter, year, month, weekday date, individual weekdays, and weekend indicator, weekend flag, month end flag, errand flag, like that. And customer dimension consists of all customer related information like customer first name, last name, date of birth, phone, email, SSN, address, and all the stuff. Okay. So customer may not be having product data, product may not be having customer data, like that. So it is an individual subject area. That's why it named as dimension and customer dimension only, particularly because customer data is only there. It won't have any product or any other dimension data. Okay. That's one particular subject area data. Thank you. Next one. What are the different types of dimensions? There are so many other types of dimensions are available. Only these things are mostly common in interview. Okay, so that's why I have listed a few of them here. One is slowly changing dimension, which is a hot topic basically in the interview. There are three types of slowly changing dimension: type 1, type 2, and type 3. There is, if slowly changing is there, then there must be rapidly growing. So it's the opposite to slowly changing. And conform dimension, role playing dimension, junk dimension, degenerate dimension. Okay, there are a couple of examples I explained in the next slides. Let us see them. Here is the rapidly growing dimension. As name suggests, it increases very rapidly, very fastly. Okay, if one or more columns in the table changes very frequently in many rows, which impacts growing table size every day. Example: if a bank company, okay, corporate, wanted to capture all ATM transactions for all customers, just imagine the size of a table. One particular customer, one particular ATM, how many times you draw a particular day in all over the world. Citibank, say for example, Citibank or Bank of America or some of them, they have banks in all over the world, right? So every ATM, each and every transaction we are capturing, that's a non-imaginable size of a table. Everyday transactions are huge. Okay? That's a rapidly growing dimension. In my 15 years of experience, I never see rapidly growing dimension because nobody want to capture all those data, which is not a useful data, right? So let us see the junk dimension here. So separating unused flag columns or indicator columns from a main or normal dimension table to another table is called junk dimension table. Okay, we'll separate unused columns from main table to a side table is called junk table. Okay, example: if a customer dimension table has anticipated flag columns like customer plan flag, customer future plan type flag, indicators. Initially, they have created 150 columns. Growing up every year, every project, it will be growing up to 250, 300. And once it is reached there, you will feel like why we need all these flags which are not at all used by this time. It's already been 2 years and we are not using them. But customers are, data architect team will never agree to remove them. So what they have to do? So we have to separate a table and put it as a junk table name, customer flag table and customer dimension table. So which will have a relational connection so that they can map it anytime for a particular dimension, particular customer. Okay, that's a junk dimension. Let us see degenerate dimension. Okay, a column or an ID that has been used in a fact table as part of the composite key, but there is no corresponding dimension for it is called degenerate dimension. Let us see the example. Example: if a fact table has a composite key like product key, customer key, time key, this combination, okay, but trans ID is something, a column which is not coming from either of the dimension, any of the dimension, but we are using it for our unique purposes. That trans ID is called degenerate dimension. Okay, because there is no corresponding dimension table for it, and there is no foreign key relationship for it. So that's a degenerate dimension. Let us see role playing dimension. A role playing dimension means in a particular fact table or in a particular design, if you are using the same table keys multiple times as a multiple different ways, that is multiple roles, it is called role playing dimension. So mostly in any fact, time dimension is multiple time used related columns, hence it's called role playing dimension. Time, product time key, product when they brought it, right? Or withdraw date time, deposit time, and all those stuff, transaction date, transaction time. This all will be a time dimensions, data. That's why role playing dimension is like mostly time dimension. Okay. So conform dimension, a conform dimension which is used in multiple schema or designs. Okay. Say for example, customer data will be used in multiple facts with the same customer meaning. Customer is customer only everywhere. Okay. Customer factless fact table uses customer dimension. There is account fact which uses customer dimension. Sales fact uses customer dimension. These are three different star schemas, but customer dimension is common in these three facts. So that is customer dimension is called conformal dimension. You the point? Let us see the important slowly changing dimension here. Okay. So as name suggests, it changes slowly. Say for example, if you have 500k customers for your bank, which come from source, how many you think changed their addresses, phone numbers, email IDs per a particular day, right? It may be 5,000, 100 to 1,000 people may change. Few hundred to 1,000 records are expected to be changed. Okay. So there are three types can be maintained on slowly changing. Type 1, it only maintains the current data. Type 2, history data will also be maintained. Type 3, current and previous latest only two records. Okay. So let us consider customer example in next slide. Let us see. So I have a source called score, which is a Oracle database, and I'm reading this data for business date January 1st, 2022. There are three customers. Okay. Sriram is living in Lombard, Illinois currently. Okay, this is active record now. Okay, while loading into dimension customer, I'm loading Sriram, Lombard, Illinois state. Start date will be 1/1/22. Today only it is starting. There is no end date, like this is max end date, and it is active record. Okay, this is the current dimension we have. SCD1. So current dimension. So slowly changing dimension current version. That is the first version I'm saying. So if Sriram, yesterday he was in, on first he was in Lombard, Illinois. On second he is in New York now. So my customer dimension will only have the current record 1, 2. See, he changed on his 2nd January. So it is only storing that New York record. There is no Lombard record in this type 1. Okay. Let us see the type 2. Okay, this is slowly changing dimension 2. First he is in Lombard, Illinois, Sriram. Second he moved to New York. Third he moved to Seattle. So as type 2 maintains history, see first record showing Sriram, Lombard, Illinois from this date to this date. On this date he moved to New York, and on second date, on third he moved to Seattle, Washington. So now he's in Seattle, Washington. That's why this is active record. All these other two are inactive records. That is history maintaining SCD2. SCD3, it maintains only current and latest previous. Okay, let us see. Same source. I have Sriram. Okay, he first in Lombard, Illinois. Now he moved to New York. After that he moved to Seattle, Washington. So in my dimension customer, I only maintain New York. That is the latest one, latest previous, which is previous one. And Seattle is the current one, current indicator, and no previous indicator. Okay, that's how we maintain SCD3. Okay, let us start understanding fact. What is a fact? A fact is a numeric data like deposit amount, revenue amount, withdrawal amount, sales amount, like that, etc. Okay, fact is usually of three types. Additive fact, which can be editable, whole column can be editable. Semi-additive, whole column will be editable by a condition or group by condition. Non-additive, that means if a particular column have numbers, but there is no meaning if you add all the column. Okay, that is called non-additive. That is non-additive. Okay, sorry. Yeah, fact table types are different than fact types. Okay, let us consider examples in the next slide. Okay, okay. So here I have a fact, account fact. Okay, so it has account key, which is also a number, account number, which is also a number, time key is also a number, deposit amount is also a fact. Like all these are a fact basically. Fact is a number, so this is a fact. So what is an additive fact here? Which makes sense. If you combine all these, sum of all account key doesn't make sense. Sum of account numbers doesn't make sense, or even time key. So these are non-editable facts. Deposit amount, this is editable fact and which makes sense. Okay. There are semi-additive and non-additive facts. Let us understand semi-additive fact here. Okay. Current balance. If you sum up everything, it doesn't make sense. But if you sum up based on the account number and time key, what account on what particular day has last balance or current balance, that makes sense. So that is semi-additive. Non-additive means exchange rate. What do you mean? What is the meaning of if you sum it up and does it make sense? No, right? So exchange rate, if you sum this up, it doesn't make sense. That is non-additive. This is non-additive. This is semi-additive. Okay, that's how it is. Fact tables are also have multiple types. Okay, transaction type, that means each and every detailed transactions based on time and maintains the history. And aggregate fact, aggregated based on a transaction fact like customer, production or product, or store based or time wise sum of sales amount, that is aggregated fact. Snapshot fact, a fact table contains snapshot of a particular point in time. This quarter, last quarter, it won't maintain the history, but it will only have current quarter data to report it easily. Okay? Factless fact, a fact table which doesn't have any fact. Example, student absence fact table, product marketing fact table. Say for example, what do you think of using factless fact table, right? So if a fact table is there without any facts, okay. Say for example, McDonald's have a lot of offers, but every time as a marketing strategy, marketing fact, they wanted to know, user or the business people wanted to know what all are the offers that customers attracted and they buy on that. How many plans are there which were not at all helpful to attract the customers? So they will do some analysis on those stuff where we don't want any fact in that particular table. That is called factless fact table. There are a couple of differences which are needed for interview, especially. Okay, so they may ask OLTP versus OLAP. OLTP means online transaction processing. OLAP is online analytical processing. OLTP is an application based ER model schema, whereas OLAP, online analytic processing, is subject oriented like star and snowflake schema. Okay, OLTP is current isolated data, current data only it maintains. OLAP is historical or consolidated data, maybe minimum 5 years, 10 years of data, but this one will be only last 1 year or max or last 1 month data. Okay, this is every detail flat relational view summarized. This is not a summarized view. Okay, this is detailed flat relational view on a relational database, whereas summarized data in star and snowflake data warehouse. Okay, these OLTPs are short and simple transactions on few thousands records, update or inserts will happen. Whereas complex heavy transactions will happen because it's on 5 years of data. Delete or update or insert is a complex heavy operation. Index hash will be on there on the primary key, but here the scanning will be historical data, 5 years of data to be scanned, so there may be some different indexes will be used here. The size of the OLTP will be transaction data only 100 MB to 100 GB, whereas OLAP is a 5 years or more than 5 years of data warehouse, then it will be 100 GB to 100 TB. Okay. Here is the indexes difference between bitmap versus B-tree. Okay. They may ask, okay, they must also not know what the difference between what is the real use of this one, but they may ask because these are the questions they can ask only while interview for the basics. Bitmap is used for columns with lots of duplicates in it. If a particular table, a dimension table has a fact table has a columns which have a lot of duplicates, then bitmap indexes will be used. Bit is used for columns which have too many distinct columns, too many distinct values in a particular columns and which have multiple columns in there. Okay, low cardinality. Bitmap is used in low cardinality data. For B-tree, it is high cardinality data. To say frankly, I don't understand the differences between these two, but I just by heart them for the interview purposes. We never know whether these are already there on this data warehouse or not, because there's like a DBA activity or DA activity while designing itself. They do these things which we may not know it. Okay, so anyway, knowing is not a bad thing. Okay, that is the end of the part one. Okay, thank you so much for watching this one. If you have any questions, I'm ready to listen. Post it in the comments. As I told you, this presentation was 90 slides, so I thought of preparing three parts. Second part will be in the next presentation. Okay, thank you so much for watching. Have a good one.